Hello YouTube. In this video we're going to look at building GUI applications with Rust. And there's a lot of different libraries and frameworks you can use to do this. And in this video we're going to take a look at a library called FLTK. And the functionality I want to build is some basic stuff that kind of gets around some of the features you will probably need if you're building a GUI application. So you can see here what we're going to build. On the left we have something that is inspired by an interesting repository I found, which I'll put a link in the description, that is basically iterating a chaotic function and showing the results here, and you can get these very interesting shapes with the right choice of parameters. And you can see here that every time, so here down here it shows you the values of the parameters. There are 4 parameters in this mathematical equation that it's simulating. Every time you click on the screen, it changes the parameters to some random value between -3 and 3. And you can also control them with the sliders. On the right, it's just some basic drawing. You can draw something like this, and then some basic functionality that takes the data that you input by clicking and does something with it. Here it's very simple. You can draw a line, you can calculate the midpoint of the shape, and you can start over. So that's what we're going to be looking at today. Alright, so here we are in a brand new cargo project. And the first thing I want to do is set up our dependencies. So let's do that. And we are going to be using FLTK, as I said. And we will also be using something called FLTK theme. Just use version 0.1, and we'll use another crate called rand for random number generation. Now that we have that, let's go set up main. Whoops. Main. And we are going to be making two like sub-programs, and we're going to put them in their own modules. So let's start by declaring them. First we'll declare one called chaos for this chaotic system that we're going to simulate, and one we'll just call draw for interactive drawing. Then let's get some imports going. So in FLTK, for some reason, you always need to use the prelude, or most of the time. We want to use app as well to set up the app, and then we want to use window to set up a window. And then we're also going to be using this theme that I talked about, and we will be needing something called widget theme and something called theme type. And we should also just use everything from these modules that we haven't defined yet, but just so that when we get to it, we will have everything we need. So in FLTK, the way it works is that you always start by defining your app, and we can just define it with the defaults. And then you make your window, which we will also do a default, and we will make it some reasonable size, like let's do like this. All right. Now everything that we put after window and before window.end, it will go into the window. That's kind of how it works. I'm not too sure exactly how it works behind the scenes, but everything you put here will be put into the window. So later on we're going to be taking something from the chaos module and putting it in here, like so. We call it chaos frame, because we'll be using something called frame that's built into FLTK. and it'll be an instance of the chaos frame class, and we'll give it some size and no label. And similarly, we will have the draw frame, which we will call something like this. So what are these numbers? This is the upper left corner position, x coordinate, and the y coordinate, and then the width and the height and the label. So we want to place this one next to the other one, not on top. And then we can call window.show. Now we don't have these things yet, so just to let's see how it works. Let's comment out these things for now and put something else in here. For example, a button, which I think is like this. We have to import it. And it will be, let's just place it something like this. And let's see if that works. Now, just to get the app running, you can either do while app wait if you want to have some kind of event loop. But for now, we just need app.run.unwrap. And if we run that, it's first spending a little bit of time downloading the dependencies and compiling them. And with enough patience, we will eventually get to something. And now finally we get something. So you see here we made a window, we added a button inside the window, we called N to say now everything else that's put below this doesn't go into the window, and we have a button that we can click. And this is basically how FLTK works. You make a window, you put things inside, and you call app.run or app.wait if you need to handle events. Now we can also add event handlers to the button, for example. So we can do like this. Actually, set callback, I think it is. So whenever the button is clicked, the callback is called. The handles general events. And for now, we can try something like this. And you see that when we click it, it writes clicked. All right, so this was the basic FLTK, but now let's try to do something a little bit more involved and implement this chaos frame type. All right, let's now make a file over here called chaos.rs. And let's actually swap these. And we can zoom in, which is usually a good thing to do. Actually, let's close the other one. So to build this sub-program, we're gonna need a bunch of things. All right, there we go. So here we have all the imports we're gonna need, and let's now define this object that is going to be the program on the left. So it's going to be extending something called a frame, which as far as I can tell is just a basic container for things. You can put in images, you can get a buffer and draw things yourself, and you can also just put in buttons and things like that. If you want to read more about it, there are links in the description. So our frame program is gonna contain a FLTK frame that you see here. And this is what we're going to be using for displaying and things. And then we will have some data that will be do this actual chaotic dynamics thing. So there will be a bunch of parameters that I call A, B, C, and D, and we kind of want them to be just floating point numbers. However, they have to be modified and accessed by several different parts of the program, which basically means it's some memory that has to have multiple owners, because it has to be modified when we call the click handler on the frame, and we will be adding some sliders that will also modify it. And furthermore, also there will be some code to handle the dynamics that needs to read from these guys. And for that reason, we're going to be using the RC, which stands for reference counted. That's if you want to have multiple owners of some memory. I don't really have time to explain it fully in detail, but you can read more about it in the Rust book. But basically, we want multiple parts of the program to own this. And then we wrap it in a ref cell so that we can just get some easy mutability without having to think too much about it. Then I also want a buffer. That is what I update and then use to draw the frame. And again, we need to access it and own it from multiple places. But a buffer is just basically a list of bytes. Then we need another number and another one. So in the preview we saw that it was drawing some black shape on the screen. Actually, it's drawing a bunch of points, and then it's updating the point and drawing a new point, updating a point, drawing a new point. And the point is specified by this XY coordinate. I will also add a scale so that we can choose kind of how much we fit into the screen. Now, if you're not familiar with this idiom, you could say, then we will often have to do something like this. When we want to make one of these RC ref cell, and that's a little bit annoying to do that again and again. So we will make a macro, which I call the RC for RC ref cell, and it will take some kind of expression and just wrap it in this thing. All right. Now let's have a look at the methods for this chaos frame. So we want to have a new function, which all these kind of widgets, they call them, need. And this is actually where most of the magic will happen. So first we make a frame, and should look like this. And now here we go. We make a bunch of these, which will be B, C, D, X, and Y. And we make the buffer 255. There should be a byte in the buffer for each pixel, so should have this size, and then each pixel has 3 different color components, which is each is a byte. So we multiply by 3 again. And now we want to set the starting label. And I want to display these numbers in kind of a nice way, so I display them with 2 decimals, and that way if you find some kind of values for these numbers that you like, that makes a cool shape, you can write them down. And now we use this ref cell thing where we say, okay, I want to borrow it, so you get a reference to the thing that's inside the cell, and then a dereference it to get the value. And again, how exactly this works is probably something you should read up on in the Rust book if you don't know, because I don't have a bit too long video if I have to explain that, as well as building an FLTK application. Okay, now let's make the event handler for the frame. And now I want to access all of this memory, or I want to partially own it inside the handler. So that's where the RC thing comes in, called clone on all of this stuff. A, B, C, D, X, and Y, Y, X, D, and C. And while we're at it, we actually also need to own the buffer. And then we make here finally the handler. So you can see I call the handle function and then I wrap it in a scope, and I can do all sorts of computations, and the return value from that scope will be the event handler. So now we handle the event, and the default is to say that we didn't handle it, and the event that we only want to handle one event in this case, which is push. Push happens when you left click or right click, and maybe also do other things. You can read about this on the FLTK documentation website. And so when we push the frame, we want to generate new random values for A, B, C, and D. So to do that, we need a random number generator. Should do like that. And then we want to do a mutable borrow of the A value and assign it to a random number between -3 and 3. And we want to do that for B, C, and D as well. Okay. Now, it's also a pretty good idea to initialize X and Y with some non-zero values, because as you will see later, if they are 0, then nothing happens due to the structure of the equation that we will be simulating. So we do this, and then we want to clear the buffer, and I'm going to be writing a macro to do that. Perhaps you could also do it with a function, but let's not dwell too much on that. So let's go write the clear macro. And it will take an identifier, and it will do, we can just call it buffer. It will do a mutable borrow of the buffer, and then it will set all the bytes to a white color. And that should be it. Okay. Now, we want the frame to actually draw something. So let us write a draw function. Again, we need some data here. Then we also need, oh, I think that's it. So every time we call draw, we just want to make an image out of the buffer. How do you do that? Call the image module in FLTK, and we can make an image out of the buffer, like so. Take the width of the frame, the height of the frame, and then we say we use a byte per color channel. Now in a fully fledged application, maybe you don't want to call in wrap here, but for now it's fine. And we can, yeah, let's do that here. Let's set the label to, actually it's kind of silly to write it all again. Probably we don't need that here, so let's do like so. But then we also need to actually get A, B, C, and D. Copy it from up here. And that should do it. So that's it for now. So now we return the value. Remember, we're still in the new function. So we need to make an object of this chaos frame class and actually return it. And the scale we'll just put to 2 for now. Okay, that's the new function. So if we try to make one now, and then run this, it will fail because we need 2 colons here. Run it again. It will fail. One more time. Because, go away please. Because in here we need this for some reason. So I forgot a key thing, which is this widget extends. So it's a macro from FLTK that tells it that this class that we have made, which contains a frame, where is it? It's up here. We've made some kind of struct and contains an FLTK widget, namely the frame. It is actually a frame itself. So we extend frame through the field called frame. Now it should work. And we need to use unused imports. Don't care about that. Here is an error. Cannot move out of frame because it is borrowed. So we have a typo here. Here we have a typo. Okay, and it works. But as you can see, we made a frame, but it didn't do anything. which is actually kind of funny, isn't it? Because at the very least, shouldn't it make a what should we call it? A white square. There we go. Now we have the white square. We just had to call a redraw. Okay, let's remove the button for now. Okay, so now we have the white square and we can change the numbers, but nothing is happening because we are not we're not doing anything. So in here in the event loop, this shouldn't be there. Let's see again. Good. So in here in the event loop, we are going to call a function on the chaos frame that we call update, and this is going to draw something to the screen, to the buffer more precisely. Okay, so this equation that we're going to simulate, it requires the values of A, B, and C, D. And we're going to be updating X and Y. And to make it go a little bit faster, then we will, in each frame, we will calculate many updates of these X and Y. So we will draw a lot of points. And we can just say 1,000. So for this number of iterations, we're going to calculate a new X, which will be the value of Y times A, this, and the sign of that, minus C times the value of X times B, and the cosine of that, and the new Y will be something similar. So this equation is not something I came up with, but you can look at it a little bit more at it if you follow the link in the description. So that gives us the new X and Y. So finally now we assign those to X and Y like so. And then we want to draw these points to the screen, but only if they are inside our accepted range, which is defined by this scale thing. And then we will call draw point, whatever, and that should be it. Oops. So to draw the point, we will need to modify the buffer. And then we need to find out where in the buffer we want to, or rather at which pixel we want to draw a point. So a pixel is an integer, so I will, or the pixel locations are defined by integers, so I will have to translate this floating point number to a pixel, which I will do like this. So here I'm just rescaling the number to lie between 0 and 1. And then we turn that into an I32. And we do this more or less the same here. So it should be Y and it should be the height. And now so now we have like a location for the point, but the buffer is a flat vector, so we need an index into the vector. And remember, they have 3 color channels, so every time we increase the column by 1, we actually go through 3 color channels. So the stride for that is 3. The stride for the Y is then the width times 3. And I think we will need this. And then just a good idea to check if this is like outside the acceptable range, then we don't do anything. And now all the buffer values, they start out being 255, that is being completely white. So we could do something like this. So here we have the red channel and we like subtract 5 from it. Now it won't work because we do this every frame. So eventually at some point, if you have you hit the same point multiple times, this will be less than 0. So we could do something like this. If buffer idx plus 0 is greater than 5, then you do it, otherwise you don't do anything. And then we do that again for like so. But it's a little bit of repeating code, so that's not good, right? We all know that, so we can write a macro for that. We call it save subtract, and we have the, let's call it buffer instead of thing. And we have the incrementer, which is just give it as a token. And then we want to substitute if the buffer, actually maybe it's not correct to call it a buffer because we want to like have an index. Maybe it will make sense a little bit. So if this is greater than the increment, then we can subtract the increment. Otherwise, we do nothing. So now we can say save subtract. Bam. I think that's pretty neat. Stop. My fingers are not doing the correct thing right now. So now we update our x coordinates, we draw points, and we do this every frame. Let's see what happens. Does not compile. Oops. Should be just like that. And it works. It's drawing something. Every time we click, it clears it. Now sometimes you will see it's white, but that's because it's just like switching between 2 points or only hitting points outside the screen, something like that. But if you just click a few times, you will eventually get to something that looks kind of interesting. Okay, now let's set up those sliders that we saw before. And there's kind of a lot of code like this, like a handle and a bunch of stuff inside. So it might be nice just to make a little bit of a macro where we can set it up. Now obviously I didn't from the beginning intend to write a macro. I just wrote the code directly, and then I saw it was a little bit annoying to have all that code there, so I ended up writing a macro. But now I will just show you the end result. Can you do this? Yes. A bit overkill. So we want a slider for each of the variables, and the macro is going to look as follows. So take a slider identifier, we take the variable identifier, take the width, the height, the number, that is kind of where is it in relation to the bottom of the frame. We take the buffer because it has to interact with the buffer, so that every time we touch the slider or change the slider, it clears the buffer, and it will also set these x and y values to 2.1. It will reset them to their initial value. So slider width and slider height is pretty self-explanatory, but slider offset, it comes from the fact that why doesn't it compile now? Error. Shouldn't be slider here, it should be identifier. Okay, the offset is from the fact that this label here will eat a little bit of the height of the frame. So we will actually put the slider at the bottom, but then plus 6 pixels. All right. So we want to make a slider with the given name. It's found in the value editor. We want to put it at the far right, but then we want the right side to be at the far right, so we have to subtract some. The width. And also minus the offset. Don't give it a label. So now we set up a handle function for this guy. First of all, we want to change one of the values, the one that's applied. So we make a clone of it, and probably just call it like that. We also need to modify the buffer. We need to modify x. We need to modify y. And here we go. This one belongs there. This one belongs there. Okay. So whenever there is, the default is we do nothing. But if we have clicked and then released, it's very important that you only update when you have released, otherwise you'll get some weird behavior. then we have to change the value of the variable to the value of the slider, which is this s parameter passed into the closure. And then we want to redraw the parent. We'll do that in the end. We want to clear the buffer. We want to reset x and y. Like so. And then we want to say that we handle this event. There we go. Let's see how that looks. Now we have some sliders. The problem is that when we click, it doesn't change the value of the sliders. So we have to go in our where we wrote the click handler and change that so that it also updates the slider values. But you can see that when we change the sliders, at least it updates the values down here. All right, so let's go down here to the click handler, and then when we change the value of a, I also want to change the slider. And here we go. And now we see the slider values are changing every time we click. So I think that's where we're going to leave it for this video. It's already quite long. And in the next video, we'll look at the second part of this application.